everyone of you is fine. Hi, how are you all, guys? I hope that every one of you is fine. So this is Sai Kiran from LetsUpgrade, and I hope that many of you guys are here along with me. So every one of you, how are you all? So चलो शुरू करते हैं. And Subrat sir is gonna be joining very soon. And in the meantime, he joins. I just want to tell you all, guys, hi, hello, and. Also, I just wanted to tell you that today's attendance form is very much special. So just do fill up your attendance form today. And today attendance form whosoever will be filling, so they have a special what we say a giveaway. One lucky winner will be having a lottery. So in that giveaway, we will be providing something very cool worth of 3,000 rupees, and it can be a smartwatch, it can be a Eco, or it can be a Google Home Mini, whatever it is. So we will decide upon it. So one person who will be filling today's attendance form and completes the whole survey, they will be, it's an attendance form with a survey included in it. So just complete it, all the mandatory questions, give it as frank as you can, and we will be offering that gift to that one lucky person in this whole whosoever fills this form today. Okay, so I hope that every one of you is all fine with it, and every one of you will be like doing it. So what do you think, guys? Is it all okay? Yep. Okay. So I hope that every one of you have got this thing. So now let me take our Subrat sir also inside this. Hi, sir. How are you? I think you're mute, sir. Okay, so day 2 attendance form, just fill up these things, guys, and all the people who will be doing it up, so they will be having the chance to get a 3,000 rupees swag from our side. As we deliver every time, we will be delivering this time also. And yeah, so that's what it is. So what do you think, guys? Will you be filling it up? Yes or no? I want to see it in the chat. And then afterwards, we will be going ahead with many more other announcements. Okay, so apart from that, guys, all the people who want to continue their journey, I hope that you all guys are loving learning from Subrat sir. So all the people who are more interested in going ahead, okay, so they can actually what we say, they can actually continue their journey along with Let's Upgrade with our professional level programs and whole bundle level programs of data structures and algorithm. So that we will be announcing in the going on phase as we progress and also. But right now, understand, learn, finish your program. That's the only thing which I wanted to say. And yeah, so that's what, guys. Thanks a lot for joining. And now over to you, Subrat sir.
Yeah, thank you for that. Hi, good evening.
Bye, sir. Take care.
Hello everyone, good evening. So it's the day 2. I hope that you enjoyed the session on day 1. So let me just take you to the quick recap that what have we learned yesterday. So we have seen some theory that what is data structure and why it is needed. Another thing we have seen that what are the career opportunities with this skill. Another thing is how can we select the best algorithm keeping in mind the time and space complexities. We had also seen some basics of Python as we are doing this whole course in Python, and it becomes quite necessary to know basic Python. So we had seen some built-in functions in Python and input and output. And now today, I think we are going to start with list. Am I right, sir?
Yes, exactly. We'll start with list.
Okay, so yeah, regarding the attendance form, as sir mentioned earlier, please make sure to fill it as we have giveaway prizes for today's attendance. And I think we can go on, sir.
Yeah, sure. We'll start session. So first of all, very good evening to everyone over there. Very good evening, Giriraj. Good evening, Srikant, Ganesh, Akash, Srikant. Okay, Srikant is already there. Like Bhavna. Yeah, very good evening to everyone over there, present there, and watching this along with us. So yeah, guys. So as Shivani has already mentioned, like what are the topics we have covered in the last session. So I'm not going into that again. So let's start with today's session. But yes, keeping the same note, we'll start with the bang. So just put emoticons, your favorite emoticons over the comment box, and then we will start. Yeah, just do it, and we would be starting this session today. We'll be talking about list operation. We'll be talking about first of all, we'll get introduced to list. Then we'll do some operations on list. Then we'll talk about the time complexity, and we'll do some problems on time complexity. Okay. Yeah, good evening, Sujata, Gopika. Yeah, just put your emoticons, guys. Put your emoticons. My voice is not clear.
Yes, sir,
Is my
it's going a bit.
okay? Is it fine now? Is it fine now? Let me know, guys,
Yes,
if
sir, better,
it is
I guess.
fine, right? Okay, got it. So, yeah, guys, just put your emoticons. Just put your favorite emoticons in the chat box, and we would be ready to start this session with list. Okay. Yeah. So, meanwhile, I'll just start sharing the screen. Okay. So here we are. Is it visible, everyone? Is it visible?
Yes, sir.
Okay. Thanks for the confirmation. So, yeah. Okay, so list, guys, we're talking about list here. So list basically it is, you can say, similar to what we have discussed in C, C++, or you might have studied array. But the thing is, array there is a collection of similar data types, but list here is collection of different data types. That means we can store different types of values in a list. As shown in the example in the slide, you can see here I've taken a list. I've taken a list li, and I've stored 1, 2, which are integers. Then I've stored a string name Raj, naam to suna hi hoga. Then I have this floating point number 3.5 and a character, special character, @ symbol, right? So I can store values of different types in a list. Okay, that's what it makes different from this array. Other than that, we can actually use this list as array. Okay. Again, some problem with my voice. Yeah, can you just check it? Shivangi, is it still a issue with the audio?
Yes, sir, a bit.
Okay, let me. So what I'll do is just be there, hang on there. I'll just reconnect my audio.
Sure. Meanwhile, I have shared the website link, guys. Do check it out, and whoever has not registered, please register. I will again share the link. Here you have the link. Please make sure that you register there. Also, guys, we will be having quizzes, and I will be sending you the link. Sir will inform whenever we will have the quiz. So make sure you attend the quizzes also. Yes, I guess Sir is resolving the voice issues, so don't bother about that. Other than that, if you have any doubt regarding the program, and just tell me how was your session yesterday and did you enjoy it? Just put that in the comment section that did you enjoy it?
Okay, so am I audible now, Shivangi? Like properly?
Yes, sir. Yes, sir.
Okay. Yeah, might have been some problem there.
Okay, I think we can continue then.
Yeah. Okay. Fine. Fine then. So I'll again reshare the screen, and we would be like good to start with. Yeah. Sorry for that, guys. Sorry for the inconvenience. Actually. Yeah. So yeah, this is list which I was talking about. So list is a basically collection of different types of values. Unlike array, rest part we would use this list as an array. Okay, we will use it operation and all. We will use it as an array. Only thing you noted down will have this values can be different actually. Values that we store in the list can be different. Okay. And one more point, if you can see in the slide I have mentioned, list is mutable. Okay, in the last class we had discussed that integer values, I had told it is immutable, we cannot change its value, right? So here I'm saying list is mutable, that means I can change its value. So let's see an example. Let's go to Jupyter notebook. We would do there some examples on list and see how it is mutable here. Okay, so I'll stop the screen here. So I'll be sharing another screen. Basically I'll go to this Jupyter notebook. Where is that Jupyter notebook? Just a moment. Yeah, okay, I got it. Yeah. So is it visible? I have already shared.
Yes, sir. It is visible.
Yeah, great. Thanks for the confirmation. So I'll just create a new file here, guys. So I'll just it will just take a moment to open up. Just a moment, guys. It will take some time.
Meanwhile, guys, you can visit the community group that I have shared the link for, as some people were asking for yesterday's sessions link, so you can have it there. Also, I'll be sharing the link here also.
Yeah, okay. So yeah, guys. So we are here. Say this. So let's take an example of a list. So I have a list here. So I'll be taking some values here, like 3, 4, and as I said, we can take some other values, kind of values also, like hello. Okay. So this is it. This is our list. So if I print here L, so obviously I'll get the same list here. Yes, I'm getting the same list. Okay. So what I'm saying is list is mutable. I can change the value of list. That means I can change any of the value here. Okay, first of all, to make you aware of that thing, uh, let me give you this property of list, that we can apply this indexing property into list. Like if I write here print L of 0, it would give me the first element. Okay, it will give me the first element of the list, that is 1. Similarly, if I give any other index like L of 3, I'll get the respective value out there. So indexing is possible in list, guys. And now if I want to change the first element, let's say 10, if I want to I want to change this value 1 and I want to replace it with 10. So now if I print here L, you see the original list has been updated. Now this value 1 has been replaced by 10. So I have changed it. I'm able to change it. So list is mutable, guys. We can change its content. Okay, we can change its content. Anyway, we don't have a string to discuss in our this course. So, but I'll just give an example over here. So even in string, guys, we can have this indexing property. Like if I write s of 1, I'll get this e, which is present at index 1. Okay, if I try to change here the first character, s of 0 equal to maybe w, let's say. Okay, if I do it, see, I'm getting type error. It says str object does not support item assignment. I cannot change the content of a string, guys. It is index, like we can apply indexing property, but we cannot change any character over there because string is immutable. List is mutable. That is why we are able to change the content of the list. Okay, is it clear? I hope this is clear, right? Okay, so what is the next thing we will discuss? We'll discuss about some operations on list. First of all, we'll talk about slicing operation in list. Okay, let's talk about that slicing operation. So I'll just change it to markdown and we'll talk about slicing. Yeah. Okay, list slicing. Let's talk about list slicing. So if I have a list, any value you can take is 10, 20, 30, 40, 50, anything you take. And what is slicing, guys? What is slicing? Slicing means taking out a part of the list. So if I take 20, 30, 40, this part, then I can call, okay, I have sliced something. Okay, I have sliced out a part of the list. This is called slicing. So let's see what are the different ways we can take out some values here. So see, guys, if I put here like 1 colon 4. Okay, if I write here 1 colon 4, what it would give me? Let me just execute it, shift plus enter, and I'm getting 20, 30, and 40. Okay, so what happened here is, we mentioned here L of, and inside this square bracket, I mentioned 1 colon 4. So what is 1? 1 is nothing but, you can say, start index. Okay, start. Then we have their end index. Okay, so when I mention start and end, this slicing property, what it will do, it will take out values from index 1, but it will give me value till index 4 minus 1, that is index 3. Whatever index you give as end value, here I've given 4, it will go till end minus 1. It will start from the start index, but it will end at end minus 1 index. So if I give you 4 here, it will go till 3. That's why I'm getting 20, 30, 40 index. If you check out the indices, that is 1, 2 and 3, less than 4. Okay, always. So it is inclusive of start index, but it is exclusive of end index. Okay, it doesn't it doesn't include 4. It is excluding that. Okay, I hope you are getting this point. Then if I now write print list of 1 colon. Okay, if I do this, I'm not mentioning the end index, guys, but I'm mentioning the start index. So it will definitely start from index 1, that is 20, but till what point it will print. If I hit like shift plus enter, you see here I'm getting all the elements of the list, like starting from 20, obviously, because I have mentioned index 1. I have mentioned index 1, it will start from index 1. As I have not mentioned any end index, it will go till the end. It will print all the elements. Okay, it will print all the elements. So in the same note, if I okay, let me do it in a different shell actually. So if I now in the same note, if I write L colon, oh, sorry, square bracket, and I just put a colon, I'm not putting any start index, I'm not putting any end index. If I print it, so if I execute this code, I'm getting all the elements of the list. So as I have not mentioned any start index, so by default it will start from beginning, from 0. And as I have not mentioned any end index, it will go till the end, till the last element. Okay, so it is actually as good as writing print L. Got it? Okay, then if you write this statement like L uh, maybe colon and 4, let's say. Okay, here we are not mentioning the start index, but we have mentioned the end index. So what it will do, shift plus enter, say it is printing from beginning. It started printing from beginning, but until like it printed up to index 3, 0, 1, 2, 3, because we have mentioned the end index, so it will go till end minus 1, end index minus 1. Got it? So this is we have done a slicing operation, guys, here. A various slicing operation I have shown you here. Let's talk about one more thing here. Okay, there are actually 3 parts in slicing. What are those 3 parts? What are the 3 parts, guys? One is start index, one is end index, and one is step value. These 3 things are there in your slicing operation. So now if I write, see, yeah, 1 colon 4 colon, okay, 1. If I mention, if I, so here start index is 1, end index is 4, and step as 1. I mentioned this. So if I hit like shift plus enter, if I click on this, so I'm getting 20, 30 and 40. So there is no change. If even if I had written like 1 colon 4, if I write 1 colon 4, it would give me the same value, right? We have already seen it. Let me also again do it here. So 1 colon 4, yeah, both will give us same value, right? So giving step as 1 is not very significant here. You may ignore it. So no use of giving step as 1. But what if we give step as 2? Let's see the difference. And also I want to change this end index to 5. Okay, so what will happen if I now hit enter? See what is this giving me? So earlier 1 colon 5 was giving me 20, 30, 40 and 50, but now 1 colon 5, when I've given step as 2, it is just giving 20, 40. So what does this mean? Okay, what does this mean? So this means I'll start from index 1, fine, 20 will be printed, then
Step is 2. Okay, so from here I'll take two steps, 1 and 2. So it will give me 40. After that, you take two steps, 1 and 2, but we are just going beyond the range of this, whatever we have mentioned, end index. So it will not print that. I'll get 20 and 40. Okay, yeah, we'll learn that today, Gaurav. Big O, big omega, we'll learn that today. Okay, this is just, we are doing the basics of a list. Let me finish with the list thing and we'll get into this time complexity thing. Okay, yeah, so this is about step, guys. This is how we used this is how we use step 1, 5 and 2 here. So giving step 2 means it would jump two steps. Okay, so it will start from 1 and then it will take two steps. So here it was, so finally it is here, one step, two steps, so I'll get 40. Let me change this, like I'll give this 0 and also I'll give this 0, let's say. Okay, maybe I'll not give any end index. Obviously, when we don't give any end index, we'll go till the end, right? So if I hit enter here, see, I'm getting here all the values 10, 20, 30, 40, 50. But here I'm getting 10, then I'm skipping one element, I'm getting 30, then one more element is being skipped, I'm getting 50. Okay, so one element is being skipped, guys, when we are mentioning step as 2, because it prints 10, then it takes two steps, so it will print 30, then two steps, it will print 50, so on. Okay, so this is how we use this indexing, slicing property, and this is what it does when we mention the step. Okay, also let me show you one more thing here. Like if I have a list here, and if I mention like this, and okay, what is the last index? Let's say 4, and here if I give you 0, and here if I give you -1. Okay, just look at it. So if I hit enter, what I'm getting, see, 40, 50, 40, 30, 20. So what happened here, guys? It started from index 4. We started printing from index 4, that is 50. Then as the step is -1, so it will get decremented. Like it will get decremented, will get down from 4, then 3, then 2, then 1, up to 1. Because end index is 0, it will not touch 0. Before that, it will stop. Okay, but the order is now decrementing as I have given the step as -1. So mine it will start from index 4. Okay, then it will give come down to 3, that's why I'm getting 40. Then it comes down to 2, so I'll get 30, then 1, 20. It will stop here as the end index is 0. Okay, I hope you're following this when I give step as -1. Okay, also if I show you this one, I can also have negative indexing, guys, in Python. So if I write L of -1, it would give me the first element from right side. Like here, see, I'm getting first element from right side. L of -1 is 50. Similarly, L of -2, I'll get the second element from right side, 40. So I can go in both direction, from left or right. So negative index would give you the elements from right side. Got it? Okay, I just want to show you one more thing here. That is the last thing in this slicing property. So if I use this last like colon -1, if I hit enter, see what is the thing we are getting here? We are getting the entire list in reverse order. Okay, we are getting the entire list in reverse order. So we haven't mentioned here any start index or end index. I just given the -1 as a step. So what it will do is, by default it will start from right side and it will like go till the beginning, you can say. So it will print the list in, or it will return a reverse order of the list. Okay, don't think that original list has been changed. If I now print L, original list has not been changed. It's still it is still 10, 20, 30, 40, 50. We are just printing the list in reverse order, that's all. Okay, so a negative index, you want me to again explain this? Okay, fine. So when you write L of -1, it will give you the first element from reverse direction, guys, right side. 50 is the last element, so we are getting here. Then what if you give 2 -2, then you'll get the second element from right side, that is 40. Okay, understood this, guys? This is how it goes. This is all about slicing operation, guys. Okay, I hope we are done with, like, you understood the slicing operation, because the next thing which I want to do is some operation, like some methods of list I want to discuss, through which somebody, I was watching out, somebody was asking how can we remove a particular element, how can we insert a particular element in a list. So all those things we'll be doing now, guys. Okay, I'll call them as the insert operation and delete operation of list. Let's do it. I I feel all of us are on the same page now. Shivangi, have we left out any questions from them?
No, sir, I think they all got cleared.
All got right? Okay,
There
great.
was a question regarding negative index that you have explained,
Okay,
and
okay, great then.
yes,
Great.
we are not. Yeah.
Okay, got it. So next, so let's do this operations of list, guys. So there are many operations, but I just need to discuss here two operations, that is insert operation and delete operation. If I want to insert a element, okay, we I think we have already discussed append method in the last class. What append does, append will add an element at the end of the list. Okay, so if I have a list here, maybe 1 2 3 4 5, and I want to append, I want to add a new element at the end of the list. So I just can use this append method and mention whatever element I want to append. Let's say 6. And after this, if I print here L, I see here, yeah, 6 has been appended, has been added at the end of the list. Okay, but now I'm saying I don't want to add an element at the end. I want to add an element at a particular position, at a specific position. I want to add them. Okay, so maybe I want to add an element at fourth position or third position or second position, or maybe you can call it as index. Let's say I want to add a new element at index 3. Okay, in that case we can go for a method called insert, guys. L dot insert. Why I am calling this method an id and type, I was calling function, but now insert and all I'm calling method. I'll come to that point. We'll come to that point in upcoming sessions, guys, when we actually cover some class and object concept, oops concept. I'll talk about that function, why I'm saying function, why I'm saying sorry, method. Okay, let's not deal with that right now. Let's just understand. Okay, this is insert method basically of list class. So how can we do here? I want to insert an element at third index, and what is the element I want to add? I want to add 12. I want to insert 12 at index 3. So after this, if I print here, print L here, you see the output, I'm getting this 12 has been inserted already at index 3. Okay, got it? Index 3, at index 3 I'm putting, I have inserted 12. So this insert method is very useful for you guys. By using this insert method, I can insert any element at any location or any index I can insert. Okay, then what about delete thing? How can we delete something here? So if I talk about delete operation, I have a method called pop. Okay, but if I just execute pop, what would happen? See, if I do this, what happened, guys? Can you note? So earlier the list was 1 2 3 12 4 5 6. When I now done have done this pop operation and I then printed L, I see here I got 1 2 3 12 4 5. The 6 is not there anymore. So if you call this pop method in this way, just calling the pop method will delete the last element, will remove the last element, guys. Okay, but the thing is, uh, we are not just intended, we don't just intend to remove the last element. We want to remove element anywhere in the in the list. Just let's say I want to remove an index, so remove an element which is present at index 3. I need to do that. Okay, so what I can do is I can use this pop method and I can mention the index 3, and let's say I'll print this list after that. So what is the output? See, guys, it's 1 2 3 4 5. So this 12 which was present at index 3 has been popped out or has been deleted. So this is how we can use insert operation and pop insert method and pop method, guys, to fulfill our requirement here. Okay, I hope we are clear about this operations like insert and pop, what they are doing. There are many operations, but we don't have to get into that. Okay, if you want to get if you want to know about all the operation and all, so you can actually, as I said already, you can attend the Python session, which is like would be starting at 8:30, sorry, 8:30. So you can also attend that. So being, we would start with time complexity next, but before that we would do a quiz actually, guys. But let me know first of all, is there any doubt? Is it all clear up to this point? Okay, yeah, somebody has asked object-oriented programming in upcoming sessions. Yes, yes, we will do object-oriented programming concept. We'll discuss that, guys. I will discuss what is OOPS concept, what is like how to deal with the class and object in Python, because that is needed again for linked list and all. So yes, we'll do that. Okay.
Also, sir, regarding the assignment, they can use any IDE, no?
Yeah, yeah,
Someone
yeah.
was asking.
Yes, yes, exactly. They just have to put the code, submit the code. Again, assignment, I guess that is not mandatory. So it is up to like it is for their practice. If they want to submit, they can submit. Okay. So yeah, index starts from 0. Yes, Kalyan Sagar. Yes, index starts from 0. That is why this is 0, this is 1, this is 2, this is 3. So I deleted an element from index 3. So 12 has been deleted. That, because that is present at index 3, so I got here 1 2 3 4 5. That has been deleted. Okay, yeah, Rohit, that is what we did here. We use index with pop. Okay, here this 3 is nothing but index. I'm trying to delete an element which is present at index 3. So this is how we can delete a particular element, or you can say I can delete an element from a particular location, from a particular index. Okay, I hope that's clear. um I hope that's clear. You can just copy Harshvardhan Gupta. You can just copy the code, whatever you would write. You can copy it and make it talk, right? Okay. Yes, we can delete element by passing value instead of index. Yes, that is also possible, but for that you need to use another method, that is remove. Okay, so let me actually take another list. 10, 20, 30, 40, maybe 50. Yeah. So if you use this remove, L dot remove, and now you want to delete 30, so you use 30, you put your 30, and when you execute, okay, let me print. I had not printed here this list, so that's a problem. See here, we got 10, 20, 40, and 50. This 30 has been deleted, has been removed. So remove method is used to delete a particular element, the object, particular object. Okay, let's not use this term object. So remove is used to delete a particular element, but pop is used to delete an element from a particular index. Okay, got it?
Sir,
Fine.
can we delete element by passing a value instead of index?
Yeah, that is what I answered, I think, I just now. So for that, they would be using this remove method. Okay, guys. So just use the
Also,
remove
can we
method instead of
replace
pop.
the element?
Yeah, I did that in the very first when I was showing the mutability feature. Yeah, this L of 0 equal to 10. So I replaced this 1 with 10 when I printed L. So now this is 10. Okay. Yeah, yeah. I
So,
will
can
share
we reverse a
Anubhav.
string by using slicing?
Yeah, the same way. However, we reverse the list, so we can actually reverse the string the same way. So all the slicing operation, guys, it's very like similar in string and list both. So if I have welcome, so I can just print here s -1. So see, we got the string in a reverse manner. No clue. Yeah, someone is asking about sharing the Jupyter notebook. Yeah, Anubhav will be sharing that. You'll receive it through your mail. You might not have received the this Jupyter notebook file in the last session. You'll get it both. Okay, in today's mail, you will get both of the file today. Okay. Fine. So I hope we have answered the questions and we are very much clear about all the concepts which we discussed about list here in Python. Okay, let's now get to this quiz actually. So Shivangi, can we have the quiz now? Can you roll out the quiz links to them? Meanwhile, I'll also show them the PPT. Yeah, this is it.
You can find the link in the chat box, guys.
Yeah, I've also shared the screen, guys. This is the link, but it is better if you get the link from the chat section as provided by Shivangi there. Yeah, delete is a command you can use, Bhavani. I'm not saying that you cannot use it. You can use it. Yeah, there are different ways to do a particular task. So whichever way you want, you can go. Okay. Can we call? Do you want to
Yes,
call or do you want
hereby
to
in.
use character, Kalyan? Yeah, first of all, let's get into the quiz, guys. Let's finish up the quiz, get back here, and we will like discuss some of your questions. Like if you have some more questions, we will discuss that. First of all, now go to the quiz link, finish up the quiz. Let me know when we are done, and we can address some more questions by you. Okay. Yeah, link has been shared in the comment section, Syed. It has also been pinned,
Yes,
I
sir.
suppose. Yeah. It has been pinned, so you can just click on that. Okay. Yeah, so we'll just wait for a few moments here. Just you finish up with the quiz. Let us know, guys, in the comment section when you are done with the quiz link so that we can proceed further with our discussion. Okay. Meanwhile, I'll just go through your chat section. Have you something here? Lord Moriarty. Okay, I could not spell the name correctly, but anyway, you're asking me to do you know any code to convert Jupyter notebooks into PDF? Yeah, I basically am trying something like latex. I have installed this latex, some mutex or something. Exactly, I don't remember the name. I have installed that, and through you by using that, I'm actually converting into PDF. So this Jupyter notebook has this option actually to download a file, download as PDF via latex actually. So you need to like install this latex in your system. Some one or two things you have to install for that, and it will download a PDF format of the same of your GPT notebook.
Sir,
Okay,
also,
guys,
Kalyan is asking using call function by indexing, can we get that string value at any index?
can we call a string by index? Is that a question you are asking?
Using call function by indexing, can we get that string value at any index?
Okay. Call function by indexing, can we get that? I didn't get
String
your
value
question
at
actually,
any index.
Kalyan. So can you be very clear? Like if you want to access any character of a string, like if you want to get the element at any particular index of a string, we can apply indexing. I guess I had shown you already. Again, um, when we are like finished with the quiz, we can get back to that, and I'll show you again. Okay. Have you done, guys, with the quiz links? Are we done, guys? Have you done the quiz? Refresh it, guys. Once refresh, if link is not working for you, refresh it once. Okay, how many of you are done with the quiz? Let me know here. Okay, I got some responses here like Puneet, Gaurav, Simran, they are done with even Harsh Vardhan has done with the quiz. Padmaja has also finished the quiz. Great guys. Can any score guys you want to share over here? Any score? No score. Okay. Yeah, see, one thing, guys, let me like clear out. If we get into more depth of Python, then we'll not be able to cover data structure and algorithm concept. This in this course, we are basically trying to um, cover data structure and algorithm concept. Whatever required of Python, I'm just taking that. Okay. Like if we get into depth of Python, then tell me difference between delete and clear. I can tell you, but the thing is that would take some time. That is not required over this course, and it is taking up our data structure time actually. If you, as I said, if you want to learn in depth, if you want to know more about very basics of Python, if you want to know it or learn it, you can attend our session. You can join on a session at 8:30 p.m. guys. Okay. Okay, fine. So I think all of you are done with the quiz link. So let's get back to our discussion. We would start with our time complexity thing. So basically, what I would do now is I'll stop the screen share this one. I'll get back to another. I'll share one more screen. Just give me a moment. Where is that? Oh, yeah, I got it here. So yeah, we've completed this pop insert and pop operation. Yeah, time complexity, guys. So remember, I had discussed in the previous session that we have to given some algorithms. We have to select the best algorithm from them. And how to select best algorithm, guys? We can select best algorithm based on two factors. One is time complexity and one is space complexity. So here it is time complexity as I have mentioned over here. So it basically gives a amount of time taken by the algorithm to solve a problem or to do a task. Okay, so whatever definition I have written here, it is like you can say as a mathematical thing. So amount of time taken by an algorithm as a function of the length of the input. I'll come to that. You'll understand this point, whatever I have mentioned there. So whatever I have like meaning there, we'll come to that. Okay, just have a look over here. Just try to figure out, try to remember this thing, and when I explain things, it would like everything will fall into place, guys. Okay, time complexity is something which tells us the amount of time taken by an algorithm to do a task. Okay, here I mentioned yes, it quantifies the amount of time taken by an algorithm to run as a function of the length of the input. Okay, I'll come to that point. What I'm meaning to say is, see, time complexity um, is measured is a measure actually is a measure of growth of your algorithm, how your algorithm grows, how it behaves when you increase the number of input, guys. When you have more input, how it behaves, how your algorithm, like how much time algorithm takes when we go on increasing the number of input. That is why it is a function of length of the input. What do I mean by length of input, guys? What is this length of input? I say n is number of input, or it can be a okay, let's take some example. When if I'm talking about an array, so there n would mean number of elements in the array, number of elements stored in the array. But if I say let's say we are talking about finding a factorial of a number, there n would mean how much big is the value, how much large is the value. Okay, so it differs here. What do you mean by this length of the input? Sometimes if you are taking array, it would mean number of elements in the array. N is number of elements of the array. And if you are talking about kind of this problem, when you are finding factorial of a number, it means how much large value. Okay, how much n is large, how much large n is. So that's what we take it. So as we increase the number of input, we'll check our algorithm, how is it behaving, how much time it is taking. So basically it would give us a rate of growth of the algorithm, guys, as time passes over when we increase the input size. Okay, actually I should show you a graph. uh, okay, I'll show you the graph, but let me just have a quick Um, I'll just give you a quick idea about space complexity, and then we can talk about graph. Yeah. So, what is space complexity? I hope it's a bit clear about time complexity. Basically, to be very specific, it gives us the time amount of time that algorithm will take up to solve a problem. What is space complexity? As I've already told, it would give us an amount of space taken by the algorithm to solve a task. Let's say we take that example, right? To prepare tea, right? To prepare tea, how many utensils you need? Okay, that would be called as space complexity. How much time you need to prepare? 15 minutes or maybe 20 minutes. Okay, I don't think it would take so much of time, but anyway, 15 minutes, let's say. So time is 15 minutes to prepare tea, but the number of utensils we would be using, one is that to filter out the tea leaves from the tea, and some container to boil it. Okay, so kind of that, and some cups to serve. So all those are space complexity. Time to prepare 15 minutes or 20 minutes just to prepare it. Okay, so that's space and time complexity. So even space complexity can be denoted as a function of length of the input. So if we increase the length of the input, how it is behaving, like what space it is taking actually. That is space complexity. Let me give you an example, guys. For that, I need to go back to our good old friend, that is our whiteboard. Okay, so it's time we say hi to our good old friend whiteboard. I'll just stop sharing this screen, and we'll get back to whiteboard. Where is it? Yeah, I got it. Okay. Yeah. Are you able to see, guys, whiteboard? Just say hi to whiteboard, and we can start it off. Okay. Okay. I just got one question here. Can we say the more number of lines of code will impact the time and space? Okay. So more the line, it would, the execution time would be more. So the more number of instructions, so obviously you are doing some more operation, but that doesn't mean that it would take more space. Space is something else. So like okay, don't I think you have taken that tea thing literally. Like if we are preparing more tea, then I need a big container, and if I prepare less tea, then I'll need a small container. Okay, I'm not saying in that manner. So basically, okay, I'll give some example. Let's hold on for a moment. It will be very much clear. Let's say, guys, um, an array is given to you. Okay, 10, 20, 30, 40, and 50. Let's say. Okay, I want to reverse this array. So there are many ways to reverse. Let's say I'm taking this way. I'm using a way where I'll create one more array of the same size, and what I'll do is I'll scan this array from reverse direction, and as I scan, I'll just copy down this value: 50 here, 40 here, 30 here, 20 here, and 10 here. I have solved the problem. I have got the solution. I have reversed the array. But at what cost? I have taken another array of size n. Total number of element was n, so I had to take one more array of size n. So here you can say the space complexity is nothing but big of n. Okay, don't take into account the given space, guys. Whatever given, the array was already given, don't take that into account. What extra space you are taking to solve this problem, that would be called as your space complexity. Okay, understood this, guys, or not? Yeah, Prashant, yes, whiteboard would be happy with you, Prashant. Okay, yeah, I hope it is clear, right? Space complexity. Okay, great. So this is space complexity. And what is time complexity, guys? What is time complexity? So see this, we are scanning here. We are scanning all the elements. So first, let me just change the color of the pen. Yeah. First, we would come here. Okay. First, we'll come here and copy it here. Then we'll come here. Then we'll copy it here. Then we'll come here. We'll copy it here. Then we'll come here. We'll copy it here. Then this one will be copied here. So basically, we are passing. We are going to each element of the array. So if there are n elements, n elements, then we'll be going to each n element. So then we say that time complexity is nothing but big O of n. Okay, we'll talk about this more. Okay, let's have one more discussion actually, very much like a very important discussion. I think we now understand what is time complexity and what is space complexity. Yes, I promised to show you a graph, right, on this space time complexity. So which would justify the definition which I have written actually. So if this is a graph, no, if not if, this is a graph which I am drawing. So this is T of n, which denotes time complexity, and this is n actually. Okay, your running time of your algorithm may be shown as this way. Okay, this is I call this as f of n, guys. Okay, I'll call this as f of n. So as your number input increases, this is how this f of n uh, behaves. So you can say yes, it is the time complexity here. Okay, at a particular value of n, we can say this is the time complexity. But there's something more to it. There is more like we'll do some detailed discussion on it. How exactly we would be doing, I'll tell you. Don't worry about it. We'll talk about various things here, like how to measure time complexity. When I say time complexity, do I mean that how many seconds or how many minutes this algorithm will take? So, like I said, when we prepare tea, it will take 15 minutes. But whether I'm saying or whether I mean here when I'm saying time complexity of an algorithm, am I really worried about the exact time it will take? Answer is no, guys. I'm not worried about the exact time, this seconds, 5 seconds, 2 millisecond it took to solve the problem. No, I'm not worried about that. It is just a mathematical representation. I am worried about, I am concerned about the order of time. I'll just show you, I'll just write an order in which I'll write the order actually dependent on n. So just the representation, guys, which would show the dependency on n, how it behaves as we increase the n. It is not like okay, it will take 5 seconds, it will take 3 minutes. So this algorithm taking 5 minutes, this algorithm is taking 3 minutes. So yes, this algorithm is better because it is taking 3 minutes. No, we are not worried about. We are not worried about the exact time, guys. We are just worried about the time complexity, the order of behavior, the order of time. Okay, not exact time, order. Okay, and we represent that in terms of n, number of input. Sometimes back in one of the batch, I got this question that so. We are talking about time complexity, so we can just run a program, we can run an algorithm, and we can see okay, this program is taking this much time and this program is this much time, so we can easily compare them depending on the time. But you need to understand this thing, guys. This is algorithm analysis. First you need to design algorithm, then you implement it. Without designing, how would you implement it? First we need to understand which algorithm is better, then you invest your time on that algorithm, you implement it, you code it. Okay, we'll not write, if we have 4 different ways, 4 different algorithm to do something, we'll not implement all the 4 algorithms just to compare which one is better. Before implementing, we would analyze the algorithm in mathematical way, which one is better, and we'll go to the part and we'll implement it, okay, in any of the language. Got it? Okay, so this is what time complexity is, guys. Okay, so time taken, and space is how much extra space. I'm talking about the auxiliary space. What extra space will be taking, that is called a space complexity. Got it, guys? Okay, so the next thing which we are going to discuss is selecting the best algorithm. I had mentioned, right? Selecting the best algorithm. How can we select the best algorithm? And there are 2 factors, time and space complexity. We now understand what is time complexity, what is space complexity. But to select an algorithm, which one would we go for, time or space? Okay, so see, guys, nowadays in the current era, space has become very cheap. With an amount of 5,000 rupees, you are getting 2 TB of hard disk. Okay, maybe with 3,000 or 2 point something thousand, you are getting 1 TB of hard disk. So space has become cheap over time. Earlier days, it was like so big, a very small memory, it would take up big space, and it was very costly. But now it has become cheap, also very compact. So space is not a big deal right now. It is not a major concern right now. But time, yes, time is a major concern. Every one of us wants that the task should be finished in like in less time, so that we'll get some free time. Maybe we'll take a nap, or maybe we'll watch some series in the Netflix, right? Okay, so that is what I got. Hello, am I audible? Hello,
Yes, sir, you are audible.
just a moment. I'm just facing some issue here.
Yes, but the video is not visible.
Just a moment. Give me a moment, Shivangi. Maybe you can ask
Okay,
them.
sure,
Like
sir.
maybe you can make some announcement if you have something to do. I think.
The quiz link, I'm getting so many comments that the quiz link is not working. Please refresh it and try again. And even if it doesn't happen, then please, if possible, then try it on a laptop. I think it would be easier on that. And also let me know just that how many of you have already filled up the attendance form, because it's really special today, as you know, sir has already explained.
Okay.
Okay, sir, are you there?
Yeah, yeah. Am I audible properly?
Yes, sir,
Okay,
audible.
fine then.
So someone
Yeah,
is asking to like explain time and space complexity with examples.
got it. Yeah, let's do it, guys. Yeah, I'll do it once again for you. So, see, okay, see, time complexity, what you do. So, you are just, let's say a machine is there, guys. A machine is there. Or let's say, yeah, a machine is there. Or let's say you have been given a task to write something, an essay. Okay, today you have written that essay in 15 minutes. Tomorrow you'll write that essay in maybe 20 minutes. Day after tomorrow you may write it in 10 minutes. Okay, so all these are variations of the like the time given the length of the essay. Maybe first day it has been asked to write down 200 to 300 words. Maybe next day it has been asked to write down the essay in 500 words. So as the number of words increases, you would take more time. Okay, quite obvious. So obviously when I take less number of input, it may take less time. When I take more input, it may take more time. So time complexity is that. So how much time it will take? I'm not, as I said, guys, I'm not worried about the exact time. We'll come to that point. You'll understand what I'm saying right now. Okay, when I say time complexity, it is not about 5 minutes or 3 seconds or to 1 minute or 2 minutes. Okay, we'll come to that point. What exactly I mean by time complexity? We'll just represent something in order of n, that is input. Okay, a function of n. Got it? Okay, and space, yeah, to write 300 words. So how much page? Okay, what is the number of page you require to write 300 words or 500 words? What is the number of pages you require? So to do a task, how much space you require? I have given the example of that tea making thing. So you can also take that as an example. Okay, guys. So I think now it should be clear about this time and space complexity. Now let's get into selection of an algorithm, how we select an algorithm based on this time and space. So as I was speaking, nowadays space has become very cheap, but time, no one has a time. Okay, no one has enough time. Like everyone needs that this task should be completed in very less time, so that we'll get some extra time to do some other task, right? Let us sleep, or let us go for a ride, let us watch a series on Netflix. So we need to complete everything in very less time, so that we would be free, right? That's where it comes. That is why I say the major concern now to select an algorithm is not space nowadays, it's time complexity. Okay, space has become very cheap, so it is like now available in plenty. So time is what now is a major concern, is a major factor in deciding which algorithm should be selected, or to select the best algorithm. Okay, got it? Okay, as I've given already in the last class, time complexity is something which tells about the time taken by the algorithm to complete a task. and space complexity is something which tells you the amount of space, the memory it would take to complete a task. Okay, in short and simple language. Okay, yeah, fine. So let's talk about here some time complexity. Okay, there are there is something called asymptotic notations, guys. Okay, there is something called asymptotic notations. So what do you know, guys? How many asymptotic notations are there? We'll come to that. What are there? What are those? So have you heard this term, asymptotic notations? Have you heard this term? When I show you some example, I think you would recognize them. Maybe you may not like remember the name exactly. So yeah,
Sir,
these are
actually we are getting a doubt if you can look into it.
okay. Yeah, yeah, sure, sure. Say,
Sorry for
what
interruption,
was the
but
doubt? Yeah, yeah, no,
that's
sure.
a
Yeah, what was the
repeating
doubt?
doubt. Sir, it would be better if you get a look into it. It's a long one. I have a doubt every time when we code, even though logic is correct, we do get runtime error because of time complexity is going beyond the constraint. But actually, how can we reduce the time every time we learn only theory of DSA, but actually how to implement?
Okay, Shravanti, see, okay, I'm very specific here. Okay, whatever you're saying that even though logic is correct, we do get runtime error because of time complexity. Yeah, so see, it's the same thing what I said. There are numerous, like n number of ways, let's say, to perform a task. Maybe you are going with a way which is taking up more time. So that's what you have to analyze different ways of algorithm, which is efficient. You have to go into that, like go to like as per that way. Are you getting my like whatever I'm saying? Are you getting my point? Who's that? Sravanti. Yeah, Sravanti. Okay, so you just need to think of other way which would take less time. Okay, and if you're doing some competitive coding, they would have given you constants, so they would not take values like more than that, like beyond that range. So given that value, it should be, you should think of a way which should do the task in a efficient manner, in less time. Okay, so if we don't have the idea about time complexity, then obviously we will not understand like what exactly this is expecting from us. We have written the correct logic, but now we understand that even if the logic is correct, we have maybe three or four correct logic for the same problem. So we have to go for the efficient one. Okay, right? Fine then. So asymptotic notation, guys. So I hope you might have seen this notations, big O, big omega, theta. But before that, I had asked you one question: how many asymptotic notations are there? And if you ask me what is this asymptotic notation, they are just a indication. Like they are some notation through which we tell, okay, this is the time complexity. Okay, just to denote the time complexity, they are the means. They are the notations. So the term is notations. Okay, through which we denote the time complexity of certain thing. Of an, obviously not certain thing, of an algorithm. Okay. Amir says there are three asymptotic notations. Yes, Ravanti, exactly. Yes. Rather than using linear search, we need to use binary search so that it would take less time. Yes, exactly. But yeah, binary search has some prerequisite. We'll talk about that later. Kashyap says 5. Shravanti says 5. Yes, Amir has put down some answers there. Big O, small o, theta, omega. Omega is also small o, and like we have small omega and big omega, guys. Okay, we have big O, small o, and we have big omega, small omega, and we have theta. No big, small theta. Okay, only theta. So among all this small o and small omega, they are actually reserved for research purpose. So we just have to take care about this big O, big omega, theta. Again, we don't have to actually be concerned about all these three right now. We just have to be concerned, or we will just talk about big O. Why big O? Let me tell you that. See, guys, there are three cases when we are actually analyzing an algorithm. There are three cases: best case, average case, worst case. Okay, so obviously when you are analyzing to algorithm or any situation, let's say, so you need to be prepared for the worst case scenario, right? Maybe you are somebody is asking you to do a task. Okay, you know that, okay, I have done this task, but I had taken sometimes 2 days to do it. I had sometimes taken 3 days to do it. So obviously you would say I can do it in 3 days, not 2 days, because worst case scenario I had done that in 3 days. So obviously, when I'm comparing two algorithm, which one is best? So I'll be comparing in worst case scenario, not the best case scenario or average case scenario. So this big O sorry, asymptotic notation is used to denote the worst case time complexity, guys. Okay, so big omega is used for best case time complexity, theta is used for average case time complexity, and big O is used for worst case time complexity. Okay, that is why we are much concerned about big O everywhere. Whenever this time complexity topic comes up, you might have been seeing big O, big O, big O. Then you might be thinking, what are these other things? Then what are they doing? Why we had been introduced to all other terms? The thing is, we are comparing to algorithm, guys. So there we'll talk about like a worst case scenario. So we'll be talking about big O mostly. Okay. So is that point clear, guys? Why we are talking big O? First of all, why these three among those five? Okay, and then among these five, why should we focus on big O? Okay, I hope that point is clear. Everyone, just let us know in the comment, guys. Is it clear up to this? What is asymptotic notation? Like how many asymptotic notations are there? Among those, these three are like for our usage. Rest two are for research purpose. Also, among these three, we'll be worried about big O, not the other two, because we are comparing algorithms, and we should be comparing to algorithm at worst case, not best case or average case. Okay. One more thing. One more thing, guys. I want to make a point here. Whenever you are comparing two algorithms, don't assume that you have a very less number of input. That is the biggest mistake when you compare to algorithm, because when you have very less number of input, your algorithm may behave differently. Let's say you have two algorithm A and B. Okay, I'll go to this. I'll just stop this screen share, and we have to get back to our whiteboard actually, because I need to take this. This is very important thing which you need to know. Okay, let me clear this out. Yeah, see guys, whenever I am comparing two algorithms, so as we had drawn this graph, right? So this is T of n, time complexity graph. This is n, the number of input. This is input, which is increasing. And I said your algorithm is taking like behaving in this way. This is f of n, which is actually the time, the growth of the algorithm. Okay, how it behaves with when we increased it. Okay, when we increase the input size, when we increase the input size, how your algorithm is behaving, this f of n shows that. Okay, let me draw one more graph here. See, and I'll let you know what is that actually. This I'll call as C of Gn. Let's say, for example, okay, C of Gn. So here, if you mark here, at this point, I'll call this point as n naught. Let's say before n naught, there was a different behavior of fn, and after n naught, there is a different behavior of this fn. Okay, before n naught, this f of n, sometimes it is less than this cgn, sometimes it is greater than cgn, so it is not showing any particular behavior or particular trend. But after n naught, it shows a particular trend, guys. F of n is always here less than c of gn. Okay, always f of n is always less than c of gn after n naught, from n naught onward. What is n naught? N naught is certain number of input, guys. So don't assume that we have very less number of input. Don't compare two algorithm assuming that we have very less number of input, because in that case you may do mistake, because in that like in that space actually your algorithm may behave differently. So always we should compare to algorithm, or always we should find the time complexity assuming that we have very large number of input, so that we can actually find a trend. Okay, this graph, whatever I have drawn here, this is actually graph of big O, worst case time complexity. Okay, this is graph of big O actually, guys. This C of Gn gives you the worst case time complexity of f of n of this algorithm, because it is always greater than f of n. Okay, outer bound, we can say outer bound. This is outer bound, C of Gn. So after n naught, C of Gn is always greater than f of n. So it is giving us actually big O time complexity. Okay, is this point clear, guys? What I'm talking about here. So don't assume that you have very less number of input while you are finding time complexity, while you are comparing to algorithm. Assume that we have a very large set of input, and then you compare. Then you try to find the time complexity. Got it? Is it clear, guys? Clear? Have you missed out anything, Shivangi, from like uh, any questions, any doubt?
No, sir, I don't think so.
Okay. Yeah, Anubhav, you have mentioned like big omega best, theta average, and big O worst case. Yes, that's right. Yeah, that's right. Okay. Not no, Anubhav, no, there is no defined minimum number of input actually. Okay, there is no minimum number defined. So because it's actually a rough estimation, it's a mathematical order. We'll say that it is in this case we'll say it is big O of n. So it depends on this n, just a order, no defined value, no particular value. Okay, so it would make sense, guys. Just hold on, we'll do some examples, we'll do some problems, then actually you'll get to know what I'm talking about. Okay, let's see some examples here, and everything will make sense, everything will fall into place. I want to show you different kinds of time complexities. Obviously, I'm talking about now only worst case scenario. I'm talking about big O of n and big O of n here. Whatever I'll denote now, whatever time complexity I'll find that in big O. Okay, worst case scenario. There are various time complexities like constant time complexity. Okay, then we have linear time complexity. Then we have logarithmic time complexity. This is linear. Okay, then we have exponential time complexity. Okay, right? So constant time complexity, linear time complexity, logarithmic time complexity. This should be single G, not double G. Yeah. Then exponential time complexity. Then also like other time complexities. Let me give you an example of this constant time complexities. Okay. See this. What is constant time complexity? So if I write a statement like print hello, for example, or maybe I'll write a statement. If you talk about C program, I'll write int x equal to 10. Okay, maybe in Python I'll write x equal to 20, whatever. So these are or unit instruction, they will each take constant time complexity, guys. Okay, each of these instructions, like very very basic instruction, this will take constant time. Okay, just let me, yeah, just a moment. Yeah, fine. So this will take constant time complexities, guys. If you take them total, okay, as in whole, let's say you are writing a program. Okay, you are writing a program, and in that program these three statements are there. So you'll say, okay, this is taking constant time complexity, this is taking constant time complexity, this is also taking constant time complexity. So total time complexity of this program is nothing but constant plus constant plus constant. So it is again constant time complexity. Okay, and how do we denote a constant time complexity? You can write big O of C, where C is a constant, or popularly we write big O of 1. Constant time complexity is denoted by big O of 1, guys. Okay, we write big O of 1 for denoting constant time complexities. So if you have multiple statement, you just have to add them up. Let's say there is some statement which is taking big O of n. Okay, big O of n, and some statement 2, which is taking big O of n again, let's say. Okay, and I have statement 3, which is taking big O of what I say root n, let's say. Okay, so if I combine them together, if I'm talking about a single program, what is the time complexity for this? Or let's say I'm talking about a particular function which has these three statements, statement 1, 2, and 3. If I ask you what is the time complexity of this function, you will say it is n plus root n, right? Okay, that becomes, so when you go for worst case time complexity, actually you will say it is n, the term with the highest degree or highest value. That is what you will say, that it is the time complexity, guys. Big of n is the time complexity here. So if you have any time complexity like this way, like 3n square plus 2n plus 5, we don't say that this is time complexity. No, what we do is, as I mentioned already, we are not focused on the exact time or the accurate exactly whatever we are getting. That is not time complexity, guys. We're just writing a order, okay, and we are trying to represent it in terms of n. So we would ignore these constant terms, and again, so left out is n square plus n. Even then, we'll not say the time complexity is big of n square plus n. We'll just go with the highest term. So we'll say time complexity for this one is big of n square. Okay, are you getting my point, guys? So I'm not saying the exact, when time complexity, when we talk about time complexity, we're not saying a very specific value. We are just giving an order of value. That's all. So all the constant terms we have to ignore, and we just have to take the term with highest degree, the highest term. Okay, is it clear up to this, guys? Or you didn't
Also,
get
sir,
it?
Man
Yeah.
is asking if you can explain that how to calculate the time complexity of recursive calling function.
Recursive calling functions will not cover in this course actually, guys, because that would take like many like that would take more time. You have to understand what is recurrence relation, and there are then various ways to find out time quantity. Then, so we have not kept that in this essential course because we want to cover. We have to cover some other topics also along with that. Otherwise, this only the time quantity will take maybe 3 or 4 classes. Okay, so I've not taken that into this course. That actually again would be covered in advanced course that is there. So we would cover, we also have to cover other things, right? We haven't yet completed time complexity of iterative code. So first we need to understand how to find time complexity of iteration. Then we can go for like this one, uh, recursion and all. So recursion has been kept for advanced course actually, guys. Okay, so yeah, these are the various asymptotic notations, guys, and this is what we actually do when we have maybe 3n square plus 2n plus 5. We'll ignore all the constant term and we'll say the time complexity is the term with highest degree. Yes, exactly. We'll do some example here right now. So constant time complexity, this is the example we had discussed. Like each statement, like one statement it is there, so each one will take constant time complexity. That is constant. Okay, what is let's see an example of linear time complexity. Let's say you have yeah, always highest degree of n is considered. Yes, because we are talking about number of input. Okay, we are denoting it or representing it in order of n. So we'll be taking into account the highest degree of n. Okay, the term which contains highest degree of n. So let's say we have an array and we just want to print all the element of the array. I think you know this thing. So I'm not writing Python right now exactly. I'm just writing a syntax here, some pseudocode you can say. I less than n, I plus plus. Okay, why exactly I'm writing this way is in Python we write for I in ARR. Okay, so it may not make sense right now. That's why I'm taking this one so that it will be very clear to understand. Same thing Python does in this way. Okay, we write print I. Okay, in C or C++, what we do, we write here. Okay, let's talk about C. So printf percentile d arr of I. Okay, so this is a simple logic which will just print all the elements of the array. So what we are doing here, if this is the array, will get to each element and print each of the element. So basically this I is running for how many times, guys? It is running for n times, from 0 to n minus 1. Total number of times it is running is n times. So this statement, this printf statement is executed for n times. Again, same thing here. Even this print statement, it is also running for n times. So we say that this is big of n. So here time complexity is nothing but the number of times the loop is running, or to be very specific, number of times the statement inside the loop is getting executed, guys. N times, yeah. So time complexity is big of n here. In worst case, it would be big of n. Okay. Let's say I'll give you one more example, guys, of this thing. Okay, if you are searching for something, let's say you want to buy something. What is that something? You can take any example. Okay, you want to buy a pen, maybe a particular pen. Okay, so there are a number of shops nearby in your neighborhood. So you'll first go to the nearest shop, right? You'll go to the nearest shop first of all. If you find that pen over there, so that is the best case. You got it like the very at the very first shop. If you didn't get it, if you don't get it there, so you have to go to the next stop, next shop, next shop. Maybe you'll not get that pen any of the shop like near like in between, and you will find it at the last shop in your neighborhood, like in that lane. So obviously that is the worst case. Okay, one more thing, that may not be the worst case. Worst case would be if you don't find the pen at all in your lane, you might have to go to other place or something. So that is worst case. Okay, right? So if I get something in the very first position, that is best case. If I don't find it at all, that is worst case. That is a simple example of linear search, guys. Whatever I said now, that is a linear search, right? We are searching for something. If we find it at the very first position, then that is the best case. We say that is big O of 1. Best case is big O of 1. We found it at the first case. Okay, but if the element is not present in the array, we may end up comparing with all the elements, but will not find how many comparisons we made. N comparison. So how many times the loop got executed? Like n times the loop got executed. We searched, we compared n times, but we didn't find it. So worst case is big O of n. Okay, that is that. So what? Okay, so worst case is big O of n, best case is big O of 1. But if anyone asks you what is the time complexity of searching an element in an array, would you say that big O of 1? Never, right? You will not say big O of 1, because you'll always go for the worst case, that is big O of n. We may not find it. That is the worst case. You'll say big O of n is the time complexity for this problem of searching an element in an array linearly. Okay, got it? Okay. Uh, Again, guys, Shreyas, you have mentioned n plus 1, right? Yeah, again, I mentioned n plus 1 can also be written as n. You just ignore the constant term, big O of n. Highest term, take the highest term, guys. Okay. One more thing. Let's get back to here. So this is actually linear example of linear time complexity. Let me give you an example of one more example. Basically, what is that? Let's say I is 1. Okay, I'll write a while loop while I less than equal to n. This is the Python logic kind of thing. While I less than equal to n. So there is some statement. Okay, let me write a print hi. Okay, and I'll say here I equal to I into 2. Okay, in Python the semicolon is optional, right? So I'll just write here. Okay, fine. So this is it, guys. This is a loop. I equal to 1 while I less than equal to n. Print hi, and I'm incrementing the I by 2. So what would be the time complexity for this one? What is the time complexity? What is T of n for this program? Okay. So yeah, we'll be always denoting it big O Anubhav, because we are talking about worst case time complexity. Yeah, what would be T of n, guys, here? What is the time complexity for this one? Who can say? If this is the code, I equal to 1, I started from 1, while I less than equal to n is the condition. And in the loop, what we are doing, we are printing hi, and every time I is incremented by twice. Okay, so initially I is 1. In the next iteration, I value would be 2. In the next iteration, value would be 4. In the next iteration, value I value would be 8, so on. Let's say, let's assume a value of n. Let's say n value is 64. For example, I just want to make you understand this concept. So next time, what would be I value? 16. Next time, 32. Next time, 64. Okay. Okay. Now we have reached the last condition actually. Okay, we have reached the last condition here, 64. uh, Beyond that, any value of I beyond this position will stop. Obviously the condition would be false, right? So we have taken n value as 64. If we exceed 64, obviously the loop condition will be false and will stop there. Okay, so you see here we started from 1 and we reached 64 in how many steps? In how many steps? In one step, two step, three step, four step, five steps, six step. So in total 6 steps we reached 64. What is this number of steps, guys? 6 steps. That means this loop got executed for 6 times. That means this printf got executed for 6 times, right? What is the relation between this 6 and 64? 6 is nothing but log of 64 base 2. As we know that 2 to the power 6 is 64. Okay, yeah, we'll do a nested loop, Tushar Jyoti. Maybe in the next class we'll do some problem of nested loop. First, understand the various time complexities, then we can apply it. Okay, Rahul. Okay, we'll look forward to it. We'll check it out, like if we can do that. Okay, yeah. See, so yeah, so here 6 is nothing but log of 64 base 2, because we know 2 to the power 6 is 64. So 6 is nothing but the number of time the loop got executed, number of time this statement got executed. That is your time complexity, guys. Okay, so this is actually T of n. Okay, number of time the loop got executed, k, or that is actually time complexity. That comes out to be log of n base 2. So here for this code, time complexity is big O of log n base 2. You can write it, or may not write it, because, excuse me, in computer science by default it is base 2. In mathematics it is base 10 by default. If you write log n, it will be base 10, but in computer science it will be base 2 by default. Okay, because everything is binary here. Is this clear, guys? Is this point clear? Shivangi, I think we had one more quiz, if I'm correct.
Yes, sir.
Okay.
Shall I
So
share the link now?
yeah, we can actually share the link. I'll just push it into the chat. Okay, push it in the chat, and they can have the quiz, and we'll continue more things in the next session, guys. Okay, yeah, I got your question, Teja. Yes, we will discuss even that. I'll continue with the same note actually. Okay, yeah, guys, so quiz link has been shared. I also will share the PPT link here on the screen. Okay, not this one, just give me a moment. Yeah, this one. Quickly finish this, guys, and we would basically finish it. Let me know, come back here, and I'll just give the final touch to whatever we have discussed, and then it is all like Shivangi's turn, like she, whatever she has to tell you or something, she would announce. Yeah, guys, get onto the quiz link. Let us know, guys, when you are done with the quiz.
Just
I hope the quiz
quickly
link is
finish
now
this
working for you
quiz.
all.
Yes, sir. I guess it is working because no one is putting any query in the
Yeah,
comment.
that's what.
So I guess.
Yeah. If it is not working for someone out there, please refresh it and it would work. Sujata has finished the quiz. Shayad, yeah, quiz to link has been pushed into the chat. Also, it has been pinned
Yes,
over
I have
there.
again shared the link.
Yeah, yeah. Thank you, Shivangi, for that.
Just quickly finish the quiz, guys, then we'll wrap it up. Sir will summarize the small things that we have learned today, and then we'll continue in the next session.
Yeah, guys. So let us know just when we are done with the quiz. Just let us know.
Meanwhile, I'm sharing the attendance link also, so whoever has not filled it yet, so please fill it up.
Yeah, Anand, you can just go to this python.org and you can download it. Okay, I see some people are saying done with the quiz. Yeah, Vikas has also done. Yeah, okay. I think like most of them are done with the quiz. So guys, yeah, that's what we did today. We basically discussed about this time complexity thing, like what is time, what is space complexity, okay, and like what how exactly we compare to algorithm, in which scenario, like how we should compare. We should not take we should not assume that we have very less number of input but very large set of input. According to that we should do. Okay, anyway, we have started with finding out how to find time complexity of a given code snippet. That is what is more important for you guys, because whenever you go for recruitment drive or whenever you are sitting for an interview, they may give you a code snippet and ask you to find out the time complexity for the code. So we have actually started it already. So today itself, like we did for the last example, which comes out to be big of login. So in the same way, we'll do more problems, more examples. Very, I have kept very nice examples for you. We'll do that. We'll try to find out time complexity, and then you can actually understand how time complexity is calculated given a code snippet. And that is what they ask, guys, in most of the interviews or most of the technical rounds. You'd given the options and all MCQs. So yeah, that is how you need to find it out. Okay, so yeah, guys. So I hope you understood everything out there. So let's meet in the next class. We'll cover up some more things. We'll cover up example. So yeah, so it's all yours now, Sivangi. You can wrap it up and we can end the session.
Sure, sir. Thank you. So let's just take a look on what we have learned today. So first we have started with list, then indexing properties. Then we have learned that list is mutable. Then we have learned a property called slicing, and operations on list also we have seen, which was insertion and deletion for to begin with. Also, we have learnt about time complexity and space complexity, about the notations, big O, big omega, and theta. Sir has told that there are a total five notations, but two are kept for research purposes, only if you missed at that time. And we have seen about these three, among which big O is for worst, big omega is for best, and theta is for average. Other than that, we have also seen behaviors of algorithm with graphs, and yeah, that was, I think, pretty much about today's session. Also, guys, keep a look on your emails, that because the summary of today's session will be sent to you on that only. And also, just make sure you have filled the attendance form. Do visit our website, and yes, join our community for more updates for assignments links also. You will get assignment links on community group only. So please make sure you join that. And yeah, I think we are done, sir.
Yeah, sure. Yeah, somebody was asking about the Jupyter file code, right? Yes, you will also get the Jupyter notebook file along with the mail, the same mail where will get the timestamp and summary. You'll get it there, guys. Don't worry about that. Okay, guys. So yeah, thank you everyone for being here. Thank
Yeah.
you for bearing me for so long. I know I have taken some
Thank you,
extra
sir.
time. So yeah, thank you, Shivangi, for being here, like for us, helping them out, also helping me out here. Okay. So yeah, thank you.